Okay, everybody, please welcome Kerri Miller.
Hey, everybody. Am I mic here? How about this? That's a little bit better. This is a strange Ruby on Ales because it feels like nobody's drinking, and I'm not drinking, so beer me. Beerus nowis. I'm not Jim and Rob. I don't always drink on stage, but when I do, it's a butterbeer. So this has been actually a really fun conference. Is Randall still here, by any chance? I was so inspired by his talk. I wanted to do my own mic drop. Actually, though, I really love math, although I don't have a real strong grasp of it. I don't have the background for it. So this is usually my general reaction to real math-heavy talks. I feel like I'm right there. Like I gotta get it. I can get it. We'll just let this loop. Thank you. That's my talk. So I want to give a little disclaimer. When I first said I wanted to do a talk, Harry Potter and Legacy Codebase, I had some Harry Potter fans say, "But Kerri, very famously, you've never read any of the books." No problem. That's fine. I watch movies. But if you're not a fan of Harry Potter, you're going to have a bad time. There's a little bit of Harry Potter in this talk. So I'd like to welcome all of you to Hogwarts Online. This is our special conclave. I'm really glad all the other speakers have presented here, but our mutual employer has actually brought us here to tackle a very serious problem. And that is legacy code beasts that are living in the basement of Hogwarts right now. Now, not everybody here knows me, which is strange because I don't know why, I seem to blend in a little bit. But I am a senior software developer from House Minneswan. I uphold the fine house traditions of funny gem names and two-space indentation. You might think with a hat like this that I'm from Texas. And then you might think, well, she's wearing tie-dye. Maybe she's from Austin. But I'm actually from Seattle. In Seattle? Yeah, Seattle. Awesome. I work for Nerd, one of the sponsors of the conference. They have the awesome pint glasses that we've been toting around and only having one drink in. We all discovered the bathroom. And I also spent a lot of time working with the Ada Developers Academy. Yes, thank you. I know a number of people, especially here in the Pacific Northwest, have volunteered or donated money and time, and it's a great program. In fact, we were able to bring 4 students came down who are sitting in the front row, and I hope that they continue to heckle me just like they do at class. This is no different. This is no different. Promises made on stage. Now, a lot of people think it looks a little bit like the Beauxbatons Ladies Wizardry School, but it's actually a... This is not a posed shot. This is the classroom. This is figuring out OAuth, and one group said, "Oh, we got it working," and the others were like, "What? I can log in on Twitter? How does this work?" But seriously, we're here to talk about monsters. Monsters in the basement. And so you're here as representatives of 3 different groups that have to deal with these monsters. And this is tough. This is a battle that happens to a lot of us from either day 1 or day 100 or day 101. Who here has seen a legacy code beast before? Yeah, a whole bunch of you, even new students, they've seen legacy code. I made them do legacy code last week. How are your scars? Do you have any scars to show? Really? Most of my legacy code scars are on the inside. These are nasty, nasty beasts that we have to face down. So how did these beasts come about? Now, all too often we assume that legacy code is evil, but it's not. It's just had a bad childhood. You know, it had a bad environment growing up. We think of legacy code as being brittle and wrong, but really we're interpreting that code outside of its context, of its environment. Like, where did it come from? What's its backstory? Legacy code is really a storehouse of domain knowledge, a set of decisions that were made by developers that came before us. It's very strange talking to a mic like this. So if we take the time to study the history of code, we have a better understanding of the business that we're working for and the context in which it was developed and the context in which we're going to be developing it going forwards. Because if software is a people problem, legacy software is also a people problem. So we've created these ideal habitats for legacy code to exist, for these beasts to rise up out of the depths and attack us. These horrible breeding grounds. And you might perceive this assignment that Hogwarts has given you as some sort of penalty. I mean, there was that incident with the visiting professor and the pumpkin and the polyjuice, but rest assured that this is not a penalty assignment. In fact, you should see this as an opportunity to earn some vital points for your house because, you know, you're a little bit behind. So every behavior that we see around us that people are doing is not illogical. For them, it makes perfect sense. People always make the best decisions they can given the time, the resources, and knowledge they have at that moment. Would people agree to that? Okay, yeah, a few people agree with that. So the people that don't agree with that, you actually go out of your way to write bad code, obfuscated code, horrible code. Does anybody here do that? Do you actually set out to write bad code? I see we have some Perl hackers here. I can say that. So when we're writing code, we have to take shortcuts sometimes, and we get sloppy, and we tend to focus on details of implementation rather than a larger picture. Or maybe we don't have complete information about what we're writing the code to do. It's a bad user story, perhaps. Or we're just not experts at it. You know, we're trying to set up some sort of DRB, distributed, crazy card shuffling system, and we don't know anything about it. You know, we're using Duplo blocks. So we don't set out to write code that is going to decay and get nasty, but it does. And when I spend a lot of time dealing with it, and I really prefer to take this evolutionary perspective to it. Thank you. Large events force their way in on code, and it can be as simple as, you know, getting a new hire who has a different style. Maybe they use Seattle style coding, right? Or we get a new data center. Somebody out there is shorting parentheses stock right now. We get a new data center, or our business gets acquired, and now we have to merge in with a group of .NET developers, or we hear about Node, and so we start working Node into our process. Something changes. And it's in that change that we start to realize this code is bad. You know, this code is no longer serving its purpose because it's evolved. It has some sort of evolutionary advantage, which is no longer an advantage. Just like a tail on people, we lost our tails when we made the migration from primates to humans. Most of us did. Moment of silence for my brother. But it's when we move into these new environments that these things that were formerly just perfectly fine traits going along happily now become expensive messes that we have to clean up. They're evolutionary adaptations that are no longer advantageous. And they'll slow us down and we'll get caught by a lion. So we're introducing a new class here at Hogwarts this semester, Code Archaeology 101. Now, in the context of legacy code, archaeology is a really great metaphor to look at. Right now, archaeology is the study of cultures that came before us through examining artifacts. You know, they'd be pottery shards or ruins or untranslatable codices. And by looking at them, we can start to understand the culture that came before us that created these things. We can identify those items that still pertain to our modern time. Hey. So, in a sense, when we're working with legacy code, we have a code artifact, and we're acting as an archaeologist to sort of piece together, how does this fit into the larger ground that we're excavating? How does this pot shard relate to this other pot shard, or this object to that service? or this comment to this, this Git commit that we don't understand. I hear some people have dealt with that from time to time. Now, there's a number of books downstairs in the library, a number of grimoires that we can look at to glean some spells that will help us cast these demons out of the basement. But there's some other things we have to think about here. We have to think about these activities within this context of what we're doing, this overarching hypothesis or objective. So now in practice, archaeology is carried out through the application of these three techniques: surveillance, excavation, and finally analysis and documentation. Each of you will end up being graded on a final presentation for this eventually. And unlike the real Hogwarts, here at Hogwarts Online, we do not give extra credit for dioramas. I'm sorry. When you're dealing with legacy code, it pays to be brave. You know, just like Indiana Jones going into that tunnel to face giant rocks and spikes and things. You know, we're digging in here to where things that will scare us. And we're going to see code that will scar us and make us want to take a drink and say, no. I've seen the worst code. Here's a flog score for you. Has anybody seen a flog score of over 1,000? How about 5,000? Do you know who wrote that method? No, it wasn't me, actually. That was a trick question. Class names have been changed to protect the innocent. When you're dealing with this legacy code, though, you're going to have to perform some mighty feats of computer wizardry sometimes. And you have to be brave and just take that plunge, like Sandy was saying, that leap of faith that this is going to get better. And it's tempting, really, to dismiss the people who came before us as doddering old fools who clung to ways of the past. We say, oh man, they were PHP developers that wrote this Rails app. There's a factory. But that's okay, because really, you have to resist this. Every line of code tells a story. Every commit was a reaction and a choice to something that was a requirement or a pressure from the environment that the person was working in. Now, READMEs are great, and tests are documentation, but they don't tell a story. They're just knowledge. They're just data. It's the wisdom that comes from talking to the people that did that in the first place that really counts. And so whenever I start a new project or go to a new company, I like to take people to lunch. I say, let's go have coffee. Tell me what you hate. Tell me what you love. What's great about working here? What's the worst thing that happens? And I don't just limit myself to my coworkers. Developers from other teams. What are they caring about? What are their horror stories and war stories? And make them show you the scars. Salespeople, great fodder for this as well. Marketing, support team, they're on the front lines. Take them to lunch. Now, in this picture, who are you? You're the red block. I knew you would be. Now, obviously, if I'm asking, right, like maybe we're Draco, are we the evil person who's coming in to spoil everybody's lunch, or are we the golden hero who's stepping in to save the day and we can do no wrong? That's a really important distinction to make when you're starting to work with legacy code, which is really legacy people, right? Because we all want to be a hero, but really what we need is more of Neville. Neville Longbottom, who is the butt of every joke and who passes out at the slightest hint of something dangerous or exciting, but he is ultimately the star, if not the hero, of the Harry Potter series, at least as I understand it. He works hard. He's smart. He got into Hogwarts, but he works hard. He tries his best all the time. And in that one critical moment where he has to make a choice and a decision, he stands up and he takes responsibility and he carries forth. So, with that in mind, I want to talk about surveillance a little bit. Now, surveillance is, in traditional archaeology, is where you measure things out with the little sticks in the ground and the little telescopes that don't really look at anything. You set out that grid and you make all these measurements. You see what's here, what do we think is here? Now, when we talk about software, we have to start by taking inventory. Where are we? Where are we starting? What's here? Do we have massive, massive problems in one particular place? What are code metrics like? How are the test coverage? Do we have benchmarks? Do we have New Relic performance graphs that we should be paying attention to? What's important here? I like asking dumb questions a lot. As most of my students know, I ask them a lot of dumb questions. I also seem to really like Ron Weasley for some reason. It's a ginger thing, I think. We have to stick together, redheads, because soul stealing, it's a taxing hobby. But ask dumb questions, because people will move forward, especially when you're joining a new team or you're dealing with, you've got that one expert who's on loan who used to work on the code who's, coming over to your team and he's like, oh, this is awful. I'm so sorry. I'm so sorry. You have to get beyond that and sort of say, well, tell it to me. Tell me the story. And ask those dumb questions about the assumptions that they're making. I've been playing a lot with this idea when I'm thinking about process, about flagging mythology, this idea that we all have, someone came out with a book recently, Software Leprechauns, talking about software development process. And it's this idea that we all have these sort of myths that we pass from generation to generation of developers. This is hard, or 90% is the 10% of the hardest, and that doesn't even make sense. But listen to the people around you, and what are the anathemas and heresies? Is everybody using Vim and they just hate on Emacs? Well, why? Ask that dumb question and think about it, because they're making a choice and it's creating an environment. And that environment might be good. It might be bad, but regardless, that environment is a pressure on how you develop and what you end up developing. Now, I don't ask people to spy on each other, even though we do have a very, very rewarding student informant program here. But all too often I hear people say, well, man, I really wanted to use Redis, but we can't because they won't let us. Right? That's horrible. Who are they? Right? Who says that we can't use something? Why can't we use something? What are the assumptions? Is it because it's a bad piece of technology? Or is it because there are costs associated with using a particular tool that the company can't bear right now? Are there alternatives? All too often we move from this idea of, that's a cool idea, this is a neat trick. And over time it becomes codified just as that's the way we do it, until finally we don't even question it anymore. Now, I spent 5 years working for a little tiny online bookstore where we had a rule in the employee handbook, and I kid you not, it said that developers must wear proper undergarments at all times. You're clapping for that? Now, why? Now, every rule like that has someone's name attached to it, right? It wasn't my name, I promise. But there is actually a story there, and I'll tell it all to you later. But the idea is, though, I'll tell you in class on Monday. But the idea is that when you're doing this exploration, right, there are assumptions that people are making about the world around them, and it's those assumptions that are no longer appropriate for the environment. And as soon as you get that friction, that is the moment where we say, oh, this is expensive. This is a headache to have to change. Sandy's example of refactoring that's code that I would leave alone until I had to make that change. Right? There's probably someplace else, there's probably some other pressure. But until that piece of code that was working, right, she made that change when she wanted to add the conjuring object or the conjuring operation. But you wouldn't touch it. You wouldn't even look at it until you had to. I mean, you're not all like me. You don't go cruising through the code base looking for things to refactor, right? Does anybody do that besides me? Okay. I'm the weird one. Let's talk about a little bit of code. I'm sorry, Renee, it's not Seattle style. We're having a little running debate. So we have a basilisk in the basement, and the number crunchers in the potions department tell us we have to remove the poison for liability reasons. I don't know why. But so we did that. But then eventually the market forces changed, and the supply of basilisk poison that was coming out of Eastern Europe, it's all dried up now. So, man, we got to save that stuff. We can't just throw that away. That's good money. And so, we make a poison barrel class, and we start to deal with that. And then we remove the poison. So what's wrong with this piece of code? Exactly. Actually, more than that, I would posit to you that any other problem that this little piece of code has, this code is lying to us right now. Because this code is not about removing poison. If you just count the pure lines of code, and if you lean back and squint, what is taking up the most amount of space? It's barrels and poison storage and finding a barrel to save this in. But we still call this remove poison. So this is lying to us. This is a trap waiting to bite us. So we take a survey, and it tells us where the most likely candidates for fixing problems are. And this is where new hires, I like to deploy new hires on this part, because they're not burdened with any sort of pre-knowledge about how things should be. So you have to dig down to find the code's provenance. How does it lie in relation to other layers of code? Right? Is it above or below? How do these pot shards reassemble into a beautiful urn? Or is it just a piece of clay that looks like a pot shard? So we roll up our sleeves and we say, I'll just do a little refactoring today. Have fun. Because you can't just blindly charge into refactoring. You have to have a plan. You have to have a goal. You have to have a set of, these are the metrics that I'm going to judge my success by. You can just dive in. But if you do, you're going to have a bad time because you're going to get distracted. Because legacy code loves to rear its head and go, boo. Show us all of its scary teeth and tentacles and gibbly bits. Because they don't want to be fixed. Right? They think they're just fine. Before you know it, you're shaving a yak. So you have to know what you want to do and get in and get out. And if you see other problems along the way that are difficult to fix, you can't get distracted by it. Leave a to-do or a fix me, open a GitHub issue, however you want to track it. Just note it and move on. But fix the thing you're there to fix. Because having a light touch is really important in making these small moves. And sometimes, yes, they add to complexity, but it's a path. And the code will evolve and continue to evolve forwards. Never backwards. How many people are familiar with the Zyder Z-Works? Okay, a couple of people. I might be pronouncing it wrong. They've been draining this inland sea in Holland since the 30s, and they didn't do it just one day, just start throwing in shovelfuls of dirt. Well, actually, I guess they did, but they didn't drain the whole thing all at once, right? They're draining pieces of this over time, and they say, well, now we need another 100 hectares of farmland, so we're going to drain that. And by attacking things piece by piece, they're able to perform this pretty amazing feat of engineering. You can see these pink areas here along the southeast and then the east coast, or the west coast of the bay. That's all reclaimed land from the sea. And they just did it piece by piece. So, back to basilisks. We go through our code and we remove the remove poison. We extract it out into the harvest poison. We sort of move along. We leave a little breadcrumb to other developers to say, hey, there's this thing here. We've changed this API. The tests are green, but we don't necessarily know who else is using this piece of code. Now, there's definitely other refactoring work here you can do. This is just me doing bad code on an airplane. But the basic idea, right, is just making a small change. Just changing the name of something gives it a different set of powers. Lets us cast different spells upon it. So finally, analysis and documentation. Once you determine the physical and logical position of a code artifact, it's time to go get published, because if we don't get published, we will die. We will not get our doctorate. And so we want to look at implementation details and identify the edge cases that are not currently being accommodated and document these, whether it be through tests or, hey, everybody, I changed the blah-bitty-blah. I've updated the basilisk class. Look out. And this is where we sort of we write down what it is we know. We're passing this information forwards and setting a standard. As you're doing this, document everything, especially if you're coming in on a new project. If you're not one of the people who's fed up and done effing around, you're starting out fresh with a brand new application. You should do that. You should follow the README. And what does the README usually say on a Rails project? Welcome to Rails. You're riding the Rails, right? If you find that, if you're lucky enough to actually have a group that says, here's your VM and here's all your databases and everything, even then, document it, write it down, and make sure that the next developer follows along. Because again, you're going to uncover things that have changed because documentation is always out of date. So by periodically going through this new hire setup process, you start to identify holes in your process, holes in your legacy code where you're making assumptions, because that's what we're ultimately chasing out. Additionally, every project I've ever encountered, every team has its own language, its own 3-letter acronyms, its own slang, its own ways of saying, oh yes, this is a process. Well, what is a process? What is an asset? What is a machine? And they define these things differently. So I like to make dictionaries, wikis, little grimoires of here's the term and here's the phrase. And I put those in the documentation and the README for my projects because the next person coming along may not have the same assumptions about what these words mean. And again, the surest way to fix a legacy project really is to address the naming errors. I make a lot of maps. I'm a kinesthetic visual learner. Does anybody know what that means? I do. I have to touch and see things. I really do. I was people who know me, I was a stagehand, and I'm also a glass artist. I like touching things, and I have a great material sense. So with my ADHD, I have to run around and play with a thing, and I can't really make a model, really, of my Rails application, right? To see where it breaks. But I can do things like Sandy was saying about generating UML diagrams that sort of show this is the logical flow of how my objects relate to each other. This is a really small little Rails project that I pulled out a long time ago, and I've seen some really gnarly ones with hundreds of classes and lines going everywhere. But you lean back and you can really see the shape of things. And so I'll take this and I'll go down to Kinko's and I'll print it on their largest format parchment. I'll just hang it on the wall. And then we have to look at it every day, and we gain a different understanding, a visual understanding of our code. And by doing that, we're engaging a different part of our brains. Even for those of you who are not visual learners, if maybe you're auditory, you'll still learn something else because you're engaging a different part of your brain. And you're creating different connections between the things that happen. Another thing I like to do, if I can't just generate one of these, if it's not like a Rails project, I will find a giant whiteboard and a veteran of the code, and I will lock the door, which is not at all creepy. Because I buy them lunch, so it's okay. But we just sit there until we go through the code, and we say, here's every little last thing. Especially on projects that have been long running without documentation, with shifting teams. This is a great way to have that sort of cultural transference about what's important and what are the assumptions we're making. Don't let them leave that room. So once you complete the surveillance and the excavation, the analysis of a legacy code beast, it's time to really move on and slay the next one. There's always a legacy code beast for us to contend with, but I have confidence in all of you, especially my students. This quote came up in someone's talk yesterday. I forget who, and I apologize. The great thing about writing shitty code is it just works, and that it's too risky and expensive to change, so it lives forever. And I was like, yes, because that's evolution, right? It has evolved into this thing that we are afraid of. It's not that the code is bad, it's just that we don't want to touch it, and so it lives on. There's this evolutionary process that's creating its long life. And when we start building more agile, little tiny objects that are adaptable, we've invented mammals that can survive asteroid strikes and what were the other, volcanoes and things like that, because they can adapt and they can move around and they're not frozen in time. And if one of them offends us, we'll just build a Walmart over it. Because, ultimately the only difference between code and a pet project that we're building on the weekend and like maybe a medical x-ray machine is really the context that we're developing it in. What are the risks? What are the environment? What are the pressures? I like to remind my students a lot that the code that they're afraid of, there's no magic in it, right? And I think that's sort of the lie about a Harry Potter themed talk, is that there's no single piece of technology or science, nothing in STEM is magic. It's all things that other humans discovered, one little tiny piece of information and knowledge at a time. So the legacy code beasts then are really phantasms, right? They're boogeymen that we use to scare new developers, people who aren't as confident that they can understand these things. By breaking the knowledge down back to these little tiny pieces that are adaptable and understandable, then we can put them in the proper context and get a handle on them. And finally, untangle their mysteries. So anyway, that's me. That's what I do, but not necessarily in that order. And I'd like to thank you. So that was a little rambling philosophical talk. What questions do you have right now? Now that I don't have to use the mic, yeah. I'm sorry? Thank you.
While you're wearing the hat, can you go back to the Harry Potter exercise game slide?
Maybe? I did find drinking game versions, and I almost put them on, but they weren't good enough resolution. So I apologize for that. Yeah. Can I say troll in the dungeon? Troll in the dungeon. No problem. Yeah, Stephen. The website is tie-dye everything. Is there any other questions? Comments? Oh, Pete. I didn't read the books, man. I don't know. I probably could, yes. Okay, so no real questions. So,
Can you actually do that? Because I didn't get them either. I'm just kidding.
okay. There is one last slide I do want to share with you that I found particularly awesome and ooh. Isn't this great? There you go. Thank you.